Starlink could be the end of astronomy. Can you believe Starlink has just launched its 5,000th satellite into Earth's low orbit? That's a ton. But little do you know, that is only the beginning of Elon Musk's plans to install over 42,000 Starlink satellites. This means high-speed internet for everyone. As appealing as this ideal may appear to the average person who simply wants to watch high-quality videos from the comfort of his own home, it is the ultimate nightmare for scientists. Their views are greatly disrupted by near-Earth objects which produce extremely long light streams when long-exposure photos are taken. Will we reach a point where we will no longer be able to view stars from Earth and would have to rely on images from space telescopes? Are we prepared to say goodbye to romantic starlight nights in the desert or in the mountains? Everything has benefits and cons, so let's take a look at what's going on here. Keep watching to learn more. Quick recap. Let us recall what these little troublemaking satellites are made of. To make them the most effective and least expensive, the satellites run on solar panels that are charged throughout the day and can power the satellite all night. This is especially essential when you need to ensure that the satellites can work continually without interruption. As an added benefit, you'll have a sustainable and clean energy source that emits no greenhouse gases or other pollutants, decreasing the environmental impact of space exploration and satellite operations. Starlink satellites are now being placed in low Earth orbit, around 550 kilometers above the Earth's surface. The goal is to establish a global network of satellites capable of providing internet access to even the most remote regions on Earth. Starlink has launched nearly 5,000 satellites thus far, with plans to deploy a total of 42,000 in the future. This lofty ambition is motivated by Elon Musk's vision of closing the digital divide and delivering internet access to millions of people who currently lack it. How considerate! Maybe you're still wondering why there are so many satellites? Given their tiny orbital distance from Earth, this is the only method to provide universal coverage. So you might question, why not fly further out and use fewer satellites? The solution is simple. This is the fastest route for information to move. When compared to GeoSat, another internet provider that orbits the Earth at a distance of 36,000 kilometers, Starlink makes 70 information round trips for every GeoSat one. That implies we have 70 times the internet speed we are used to. And who wouldn't want it when you're deeply immersed in a zombie-killing video game or having a great time on a video conversation with loved ones? Stars or Elon Musk? Elon Musk seems to be everywhere these days. You look to your right and see a Tesla, and to your left, you see his face next to Mark Zuckerberg's wanting to meet up for a physical fight. Now that he has effectively conquered our Earth, he intends to conquer everything around it. Jokes aside, a natural inquiry arises. How do we know what we're looking at while lying down on the grass to stargaze? Are we genuinely stargazing, or are we Starlink gazing? And how would the vast number of satellites affect ground-based astronomy? As an astronomer, I would undoubtedly be furious. But Elon Musk has an answer to everything. As the scientific community began to fight against the deployment of new satellites, Starlink came up with a solution: dark-coated satellites. So how does it work? Dark-coated satellites are designed to have a lower reflectivity, making them less visible from the ground and reducing the influence on ground-based astronomy. This covering would lower the quantity of sunlight reflected off the satellites, making them look darker and less invasive during observations. On the one hand, this appears to be a positive step toward addressing astronomers' worries. It demonstrates that Elon Musk and his colleagues are aware of the potential impact their satellite constellation will have on scientific research and are taking steps to mitigate it. After all, astronomers rely on bright and dark skies to collect useful information about the universe. However, some astronomers are skeptical about the usefulness of dark-coated satellites. It is stated that even with reduced reflectivity, the sheer number of satellites in low Earth orbit may make it difficult to observe dim celestial objects or distant galaxies. The issue is that even if the satellites are dimmed, they may still cause streaks in long-exposure photographs or interfere with telescopes' capacity to identify and study distant astronomical occurrences. Furthermore, Even if dark-coated satellites are successful in decreasing their impact on ground-based astronomy, astronomers have voiced further concerns. One key concern is radio interference. The Starlink satellites communicate using radio transmissions, which may interfere with radio astronomy observations. Radio telescopes already struggle to mitigate interference from numerous sources, and the advent of thousands more satellites in close proximity exacerbates the problem significantly. Space debris. Another concern is the possibility of space debris. With 30,000 satellites slated for deployment, the potential of collisions and the formation of space debris rises considerably. This debris threatens not only other satellites but also the International Space Station and future space missions. The accumulation of space junk in Earth's orbit could create a hazardous environment, limiting human ability to travel to space. Oh great, just what we need. Space junk. As if traffic on Earth wasn't bad enough, we now have to deal with interplanetary traffic. Can you conceive a space version of rush hour? Sorry, Captain. We'll be delayed. There's a jam on the way to Mars. Let us not forget about the wretched International Space Station. It's already floating up there, minding its own business, and now it needs to avoid deadly space debris? But in all seriousness, this issue emphasizes the value of responsible space exploration. Let us hope that when we travel further into the universe, we will discover ways to clean up our space trash. Otherwise, we may have to start conducting interplanetary yard sales to get rid of all the space trash clogging up our orbits. Elon Musk presents a solution and once again demonstrates how to conduct business. He envisioned updating his Starlink mega constellation with new technologies every 5 years. When these satellites reach the end of their lives, they will be purposefully steered into Earth's atmosphere where they will burn up. While this is undoubtedly a helpful step toward minimizing space debris, it rapidly brings up another issue: the large number of satellites burning in the higher layers of the atmosphere. This will have unforeseeable consequences for the planet's atmospheric chemistry. According to a study published in Scientific Reports, burning the aluminum utilized in these satellites produces alumina, also known as aluminum oxide. Alumina has the potential to reduce ozone levels and interfere with the atmosphere's capacity to reflect heat. These alterations to Earth's atmospheric chemistry may have unforeseen effects for the planet's climatic equilibrium, resulting in an uncontrolled geoengineering experiment. However, the long-term consequences of these changes are still unknown. The issue is that these particles in the high atmosphere could remain there indefinitely. While there will be fewer satellites burning in the atmosphere than meteorites, their chemical composition separates them. The first generation of Starlink alone might result in around 2 tons of dead satellites re-entering the atmosphere each day, as opposed to the 60 tons of meteoroid material that enters the atmosphere every day. Meteoroids are generally constructed of rock, whereas satellites are mostly made of aluminum, which is found in meteoroids in trace amounts. Aaron Boley, a researcher, cautions against underestimating human potential to change the environment. He compares the issue to ocean plastic pollution and human-caused climate change, highlighting the significance of not repeating our mistakes in space travel. The train. Despite all of the terrible implications that Starlink is having on scientific study and our planet's habitability, it is still a beautiful sight for us to see the famed train of lights pass by in the night sky. Let us see how you can recognize them, and if you're lucky, you might be able to do it yourself. There is a time and place for everything, so take careful notes since this is important knowledge. The key to identifying the train of lights is to observe the sky shortly after they have been deployed. And luckily for you, the launches happen virtually every week, so stay tuned for the next launch, which is planned on April 6th. Starlink seems to be generating quite a stir in the scientific community. Astronomers are outraged that their observations have been disrupted, potentially resulting in the loss of romantic stargazing nights. But don't worry, Elon Musk seems to have a solution for everything. Let's see what he has planned for us. So while we may enjoy the view of the train of lights traveling through the night sky, there is much more to consider when it comes to Starlink. Alright folks, that's all for today. Thanks for watching. Keep curious, keep starry-eyed, and remember that there's an entire world out there waiting to be discovered. Until next time, continue to aim for the heavens. Don't forget to subscribe and hit the bell icon to be updated of our latest space developments. And please do not hesitate to leave a comment.